It's been a couple of weeks. I've been designing more parts for the video synth on the computer. First time ever really using easy EDA. It's a lot of fun, bit of a learning curve, but not too bad. But we have, straight from Shenzhen, we have a first set of PCBs for the video synth project. I have decided to abandon the rat's nest approach to prototyping. It's gotten me pretty far along, but it's just getting too hard to manage all the wires and the issues that I ran into last time. So I have some 4-layer PCBs that got manufactured by JLC PCB. First time ever doing a 4-layer PCB, first time ever using this service. I got them to install some of the SMD components, but not all of them. They didn't have everything in stock, and there was a very high fee for custom parts. I don't have super high hopes that this is going to work out of the gate straight away. There may be some bodge wires involved. I don't really know what's in this box yet. I thought it would be exciting and possibly educational for us to open this up together. So let's do that and maybe learn some lessons along the way. All right, here we have the package. I've already got all the components from Mouser that I need to complete what's in here. I have my trusty maker knife. So I guess we should strap in and open this up and see what we've got. All right, so I think I got 5 for the price of 1. Looks pretty good. Probably did not need to use the full 4 layers to fit everything on here. It's always hard to get a sense of scale, especially when it's been a while since I've designed a PCB. But that layout looks pretty good. What I really should do is print out a copy of the schematic and the PCB design so we can go along through it. I'll do that and bring you in for a closer look. Okay, so here is the schematic and the PCB. The PCB, as you can probably tell visually, is separated into 2 components. Up here we have a dual rail plus and minus 5-volt power supply. There's an unpopulated regulator here, which also gives us 3.3, which this circuit doesn't need, but it's useful for other stuff. Down here we have the 3 channels of the component video signal that are impedance matched, amplified, and then up here some unpopulated ICs do the sync separation and then the signal separation of the luma and the sync. Then some inverting amplifiers which allow us to do some color stuff, and then outputs here. These are jumpers that then go off to another board that allow you to sort of do the color correction and things like that. I think probably the best place to start in working out where this thing works and where it doesn't work, because as I said, my hopes aren't pretty high, is to test out the power supply. Now, it's designed to run off a 9-volt AC power supply. It's a pretty standard configuration. You've got some input filtering. We're missing these large caps here. They're not really necessary. We have 2 1000 mic caps there. They should be fine. 7805, 7905. Rather than sticking in 9 volts AC, what I think I'm going to do is just put power, some DC power in, 5 volts DC, and see that LED light up. That confirms that all of this works. The reason why I'm going to do that is I can watch the current draw on my DC bench power supply, whereas plugging in a wall wart, if something goes catastrophically wrong, we could have some very good YouTube content, namely smoke in my face, or I don't think any of the caps will explode. But anyway, let's turn on the bench power supply, and we're getting off to a good start. The jack that I've designed to fit here doesn't actually fit any of the jacks that I own. I'm not sure what footprint I selected in easy EDA, so I think I'm gonna have to solder a couple of jumper wires on here to allow me to connect my DC power supply. So I'll do that, and let's give this thing 5 volts. All right, looking at that trace there, that should be where I put in the 5 volts positive. That will then power up this half, which is what powers on the LED. So let's have ourselves a nice LED light show. So what did I say? This one's positive. This one's negative. And we'll dial in 5 volts on the power supply. I'll set the current limit to something sane like 50 milliamps. It should not be drawing that much, especially with most of these chips not populated. Let's turn it on and light show. I don't want to block the camera for this glorious moment. Huh. That's less glorious than I was expecting. It's capping out at the 50 milliamps and just only sending a little under 3 volts through here. So I'm going to turn that off. And I mean, that doesn't sound like a dead short, but it doesn't sound good. I mean, this is a really simple power supply circuit. Let's measure the resistance across the power supply input. Well, let's first check for continuity. No continuity. Got the 2 meg range. No, nothing. Where could this go wrong? I mean, I've used this topology for power supplies forever, so let's check the other diodes. They could be faulty, but kind of unlikely. And I really doubt it's anything down here because most of the chips aren't populated. It could be these guys. These are just 4000 series CMOS, so I mean, everything else here is these capacitors and resistors are all in the signal path. For the component signal, we have a 75k resistor here, the capacitor to AC couple. Then this is the input, the RI for the op amp. Then this is decoupling capacitors. Then RF for the op amp. What's R7 and R8? It's a riddle wrapped in a mystery. I'm going to go back and look at the PCB layout a little bit more. Well, my friends, this board is toast. I was visited by Mr Bozo. While I've been waiting for these boards to be shipped, I've been working on a second design, which is another 4-layer board, but it's a frame buffer. It's a much more complicated design. And in the process, I've learned a lot more about how to use Easy EDA. One of the things that I learned is that the design rule check tab along the side here doesn't automatically update. And while it had 0 design rule errors minutes before I went to press print on this, I got a little ahead of myself and I moved some of these components around a little bit just to get the alignment right. The traces followed through. I didn't see any sort of design rule check errors pop up, but there are a few here now that I've hit refresh. And here is a prime example of the problem. This is one of the high speed, high bandwidth op amps. And there's a ground pin, a 5 volt pin. This is all the top layer that we're looking at. I moved this guy down, I guess it was, and the trace came down with it for the 5 volts coming from the decoupling caps here, and it's hit directly into the ground pin. So I have a direct short across my 5 volt and ground rail on the other side of this regulator, which is why I wasn't seeing a short here, but there's a direct short there. I could maybe get in there with an X-Acto and cut those traces. It's pretty small. I think I'm just going to respin these up. I've learned a lot more, as I said, in this new design that I've been working on. Hey kitty. For example, I've got a separate 5-volt analog, 5-volt digital power plane, or separate copper pores inside that for my new design, so I'll do that again for this one. I said I'd learn some lessons in this video. I wasn't expecting the lesson to be this embarrassing. I was hoping for some interesting parasitic capacitance or something like that. These guys will make good art, possibly some sort of sculptural piece, or maybe I'll just hide them in, hey kitty, the trash bin of shame. So yeah, I'll be back in a few weeks when I've spun this guy up again, and we'll do some more progress on the video synth. I might spin up the line buffer, frame buffer boards as well too. I might do them all on one board. Who knows? Let's see where I'm at. See you next time. Bye.